when I started out, I was a contract worker in validation, and Jesse was the driver developer. So it was my regular pleasure to say, nope, I can come up with a test that breaks this, I'm sure of it. And so my introduction to some of his code, I think was, E1000, I think, back in the day. Do you remember that card I held up? He's one of the guys that actually was working on drivers for that stuff way back when. And so I think my first real time doing any of that kind of stuff was, I think you introduced the first page-based receive, really, for E1000, come to think of it. So yeah, so version probably 0.1 would have been E1000 code written by Jesse for all that page-based receive stuff back in the day. So trying to think, what else is there to say? He likes race cars. You want to ask him about any race car stuff, I'm sure you can get him talking for a while. Yeah, that's pretty much all I've got to say. So take it away, Jesse.
Thanks, Alex. Hi, is this thing working now? Okay. So let me get my slides up here. I guess I don't need to introduce myself now. I've been working for Intel for a long time. Hello, everyone. I want to thank the organizers, Jamal especially. I know this doing a show like this is a ton of work, and I really appreciate them doing this and giving us the opportunity to talk to each other, and also for me to give you guys a chance to see my presentation and to talk to you. So let's get started. Network infrastructure, right? We all know this, but you can't see it, but really you can't live without it. How many of you have a phone in your pocket today, right? Pretty much everyone, I hope. You know, it's connected to the network. It wouldn't work without all the network infrastructure, right? We work on that. It's important. Linux is making most of that infrastructure hum today. There's a few places where Linux isn't, but not many. So, but most of the time, and we think we need to help advertise this to the community. Most of the time, the users don't realize they're using Linux. We can tell them, hey, we work on this stuff that makes your guys' phone work. So, looking at the back at our network, right? Where have we been? So, Linux started back a long time ago, back in 1994-ish, with the 1.0 release. Back then, there was 10 network drivers. They were maybe 250 to 1,300 lines each for roughly about 10,000 lines of code. So where are we going, right? This chart was actually pretty interesting. Once I built it, I didn't know it was going to be there until I saw it. The back line is, the light blue is the driver's net directory and the lines of code as measured by slot count. And then the front line is the net directory. So you can see the driver's net directory is growing pretty fast. The core code is also growing, but the driver's net directory is growing a lot faster. And this is pretty much equally split by both wireless and Ethernet drivers. So you know, they fight over who has the most lines of code in the driver's net directory all the time. We may want to try and think about what's happened here and then what we want to do to help mitigate this, because I'm not sure that, you know, the growth chart, if it keeps going at this rate, we're going to be at 3 million lines of code in driver's net in a couple years. How much code does Dave want to maintain? I'm not sure. So another good point here is in 2009, roughly, is where virtualization was introduced, the first virtual driver IGVVF from Intel. And you know, maybe we can slow things down a little bit by making more code common. Do you guys remember back in 1.0 when we were all using modems, and maybe you had Ethernet at work if you were lucky, and maybe it was plugged in over a BNC connector or twisted pair AUI? Some people here may not even have been born yet. It's disturbing. So Intel's been around for a while, working on the network. Intel's been around Ethernet since the very beginning. You know, this is just a little bit of a brief history, but I'm not going to go into a whole lot of detail here. This is kind of more for the recording. So what's happening today? The data growth is massive that's coming. From 2006 to 2016, the compound annual growth rate was 78% of network traffic, right? So the network traffic is increasing like crazy. From in 2010 to 2023, it's going to go by 1,000 times. So there's a lot of networking work to be done. I'm not even sure that we understand in the network community how much data we're going to be carrying over the Linux kernel and having to process. A lot of this becomes important to us because we have to start figuring out all the different, what does this mean to the network and what does this mean to the kernel? So with that in mind, we'll go to, everything is on the network, right? All these devices are coming, all these computers, all these phones, everything's going to be on the network. So, everything's on the network, and the network runs on Linux, really. From the device to the data center. So this is just a summary slide about what's going on in the network today. We have, all these devices connecting from wireless to wired and going through all this infrastructure and then into the data center. In this picture, Linux is all over the place, right? You can think Linux is obviously here, well, but Linux has been moving into this area quite a bit, and Linux is even moving out into the edge. What's happening is high-speed networking is also going to be moving from this direction, right? It's going to be moving from the data center out towards the devices as device networking gets faster and faster for instance, 5G, like Tom was talking about earlier in his IoT presentation, right? We're going to need these fast connections to provide all the services that people want and that companies want to deliver, one of which is mine. We want to deliver wired and wireless. As Linux moves in this network, Linux moves from right to left. Doing things like having BBR deployed or some other machine-learned congestion control algorithm get a lot easier, right? Especially if the ecosystem is more uniform. So there's actually some advantages for us being part of that ecosystem that's being spread across all the devices, from Android all the way to little tiny IoT devices. A lot of stuff is run in Linux today. So say it again. Everything's on the network, and the network runs on Linux. There is 50 billion devices are going to be connected to the internet. This is unfathomable, right? All these devices are going to be generating data. They might be connected via your phone. They might be connected themselves via wireless. They might have a wire if they're in a factory. They might be your car. So more and more devices and things are coming. It's going to really change our world quite a bit. The thing that's common among all these is the network, right? We are the providers of the network in a lot of cases, and all these devices are going to be talking to someone or something, and the network's going to be providing that. The network is critical to our new economy, right? This is give you a bit of an idea about how much data is going to be generated by all these connected devices. It's crazy. It's really a flood. You're talking about autonomous driving cars generating up to 1 gigabyte a second. Maybe a smart hospital might be generating 4 terabytes a day. So, and connected factories might be generating 1 million terabytes a day. All this data may not be consumed or stored, but all these things, these connected devices, are going across the network, making their way into data centers or into centralized storage. So storage is a big deal. Making their way across the network with meeting all the needs of all these devices is a huge, huge concern. Everything's on the network. The network runs on Linux. Don't forget that. So what's going to happen with the Internet of Things? There's everything in the network's going to grow, right? We're going to have to scale up. It's going to be a big deal for both us as providers of network gear and computer systems and all the parts in between. Through a lot of other companies here doing software or us doing software, the network is going to use much more bandwidth, have a lot of concern and a lot of importance in the technology as we go forward. It just has to grow. The scale and scope is growing exponentially. So this guy looks like he's having a great time, doesn't he? All these devices like VR or all these technologies are going to be using more bandwidth, right? We've increased our scale and scope. It's going to be using more bandwidth. It's going to require a bigger network. All these things are dependent upon the network, and they're enabled by the network. So even though you might have a big data center providing all the VR experiences, or even steering all the people so that are in this big multiple-person world, they will be cloud connected, they'll be using lots of bandwidth, and they'll be dependent upon the network. Like Tom said in his presentation, and in some of the other IoT presentations today, ultra-low latency is super important, especially to vehicles, but we're also talking about other devices and other experiences that are going to need a lot of low latency. The network is going to have to provide that. We're going to have to satisfy these new demands being put upon us, both in hardware and in software. Especially 5G is going to push lower latency, and vehicle-to-vehicle communication or device-to-device communication is going to be a big deal. All these Internet of Things thingies need security too. Tom talked about it a little bit. We think about it a lot. What does security mean in the design of communication, right? End to end, it's got to be secure. These devices have to be able to be designed from the ground up to be secure. We, as a Linux ecosystem or Linux providers, need to be providing easy-to-use solutions, not just technology, but easy-to-use solutions that people will want to use because they're right there and they're open source and they're easy to use. If there's something that's easier to use, some companies might pick it up, and we end up with this kind of fractured ecosystem like has been happening with the IoT devices today, where you have devices full of security holes using old technology because it was the first thing that somebody found when they Googled for web server, right? They pick up a web server from 2006 that has just full of zero-day holes that were already known. This may have been relevant to the camera exploits that were recently in the news here not too long ago. Another point about this is that the Linux kernel network stack is the best place to do truly secure communications, right? Doing it in user space apps is not the greatest way to do it because, and I firmly believe this, the kernel is providing this layer of both robust security and tested security, and it's tested over and over again by being in every layer of that previous slide that we saw, from small devices through infrastructure and out to the data center. Another thing is that hardware offload for security is really important. Sometimes the big computers can help you out and do it fast. Other times, you're going to have a tiny computer, and it's not going to be really capable of providing security. This hardware offload in these small devices is a big deal, and I think it's going to be really important going forward. It's no longer an option, it's required. So once you've got all these things, you've got ultra-low latency, huge amounts of traffic all coming in the data center, what are you going to do with all this data, right? It's going to be stored, probably. That's a big deal. But it's also got to be processed. There's got to be some usefulness of all this, otherwise why are we gathering all of it, right? AI is the thing that's going to be causing or helping us understand or finding meaning in a lot of this data. Sometimes AI comes up with really funny meanings among data or things that you don't expect. There's a lot more data there than we can really comprehend as people. The computers don't have too much trouble understanding it. But AI is the only way to make sense. But remember, the network is the path to the storage. The network is the path to the data center. And the network is the way that the AI uses to communicate between all of the different endpoints and out to the devices. Tom's devices that he was talking about earlier in an intersection might be having AI in them, but I think a lot of the learning that those devices are going to be capitalizing on is going to be done in data centers and over the network. really. The AI is dependent upon the network. So just as an example, here's an example of putting it all together, right? From end to end, the autonomous driving is a really hot topic today, and all the bits come together here, right? We have the cloud, the core network, and the access, and then out to the wireless technology going out to the devices. How many parts here in this picture do you think will be running Linux? Probably a lot of them. The network is there all over the place being used. Many companies that they'll believe that today that we'll be having autonomous driving by cars at least level 4 and probably level 5 by 2020 or 2021. This seems pretty optimistic to me, but we'll see what happens. I mean, they keep on surprising us going out and driving around cars by themselves, right? So the thing is that we as network providers need to be providing the solutions that will help these things succeed. And by we, I mean the Linux community, not just Intel. And even as soon as 2018, we'll have cars coming that will be driving themselves. And you've seen it today already in the news, right? So remember, everything's on the network, and the network runs on Linux. So also, remember when your car is driving around down the road that it's probably talking over lots of Linux machines and using technology that was at least started in Linux, if not using it all the time at the moment you're using it. So what's in store for us next? Maybe even you could call it Intel Next. So Switchdev is the way that we're moving forward on with our products that have anything to do with Switch. So we're going to be actively developing in that space, especially things that have virtualization support. We're going to be using Switchdev to help both connect that to the host and configure it. As of today, we believe that Switchdev is the right path for us, and we're going to be contributing to the community. And the contributions have already started out on the list. You may have seen some of the stuff around I40E coming out. So as far as the future goes, the speed march continues. 100, 200, 400 gigs. There's even rumblings about terabit Ethernet. I don't know what that's going to mean to a server or a cluster of machines, but it's going to be a big pipe. We have new drivers coming soon. Hopefully we'll be able to get them upstreamed. We're very interested in doing more connections of TC, using TC to add hardware filters. It's a big deal for us, and we are trying to figure out what parts to connect and what parts TC is missing so that we can extend it to make sure that it works right for our users and for the community. We're also looking towards DevLink and trying to figure out what a complete Switchdev ecosystem looks like so that we can actually deploy it on our hardware. We have lots of things we can't talk about yet. We look forward to our close collaboration with the community. So we see huge benefits at Intel to using open source. I'm a big fan myself. I have been for a long time. I really appreciate that I can actually look at what's going on in the stack. I can talk to people who are unencumbered and willing to talk to me about what's going on. I can help fix things when I see that they're broken. And we're a huge believer that it will increase the ability of all of us to use and benefit from all of these things. So let's work together to make Linux the best choice for networking and see where the future can take us. So remember, everything's on the network, and the network runs on Linux. Yeehaw.
Questions? Comments? There comes Tom.
Tom.
IoT.
Thanks for the presentation, Jesse. I really like that you mentioned AI again. That's cool. You mentioned crypto offload being required. I find that kind of an interesting statement from someone coming to Intel. So the history of this, obviously we've wanted this 20 years ago. Several vendors back then tried to put IPsec in the devices. A long history of it almost works, it doesn't work. And then every time it seems like Intel just comes up with a new instruction set that kind of obsoletes that technology.
Yep.
Do you see something different now, or are we at the limits of like what's going to be in the CPU, so we have to offload it to a device, or is this are you referring to some sort of in-CPU offload for the crypto?
In my mind, we're thinking about how the crypto is sometimes limiting when it's provided by offload devices like loci-side offload or in the CPU. So the CPU might be able to do it very fast, but then you can't get it on the network as quickly, right? That's the case with IPsec today. If it's done in the CPU, it ends up having to be, it can't be segmented by the hardware segmentation engines on the device. So you only get like one CPU's worth of throughput from a single IPsec connection, right? So that's the kind of thing that I'm talking about where, and especially like with tunnels, we want to be able to encrypt tunnels. And a lot of times you don't want to even be telling the network consumers that you're encrypting the tunnel, maybe for an SRIOV device or for a container or for something else. You may want to just stuff data in from the application side and have it be encrypted on the network. So I'm a firm believer that you can't really accelerate traffic onto the network unless you have good offload that includes encryption. So things like TSO.
So thinking about the 50 billion number, though, I'm skeptical those are going to be using IPsec. If anything, they would probably be using TLS over TCP, but TLS is really hard to offload. I think we're making some good progress on that. So I guess I'm saying it's an interesting question, but I'm still a little skeptical that crypto offload.
Yeah, I agree. Crypto offload's a really hard problem. And like I said, I think that in order to have secure communications, you got to have the devices being secure all the time, right? If you offer a device that doesn't use crypto, people are going to buy it because it'll be cheaper, right? And then all your IoT device stuff is running out in the world unencrypted.
Then I burn a CPU. So which is cheaper, CPU or the device?
That's a good point. Thanks for your question.
All right. Thanks, Jesse. Let's give him a hand of applause.